Students, hello again. This is Neha Mathur and today I am taking up the another most important application of semiconductors, which is transistor. Basically, transistor is of two types. One is bipolar junction transistor. B stands for bipolar, J for junction and T is transistor. And the other type of transistor is UJT, that is unipolar junction transistor. But today in this video I will let you know about the BJT, that is bipolar junction transistor. So for the today's lecture our topic is bipolar junction transistor. I will start with bipolar junction transistor, that is BJT. Bipolar junction transistor. Basically, transistor is a three-terminal having their name emitter, base and collector. Two junctions and bipolar device. Two junction, three terminal, two junctions and bipolar device. What happens is, basically transistor is a very basic component of electronic circuitry, or you can say that this is just a backbone of any electronic circuit, because whether we will go with the designing of any kind of amplifier, any switching circuitry as well as any oscillators, you must have idea about the complete principal details of transistor. So before start any electronic circuitry, you must have idea about the physics of any transistor. So in today's video I will discuss about BJT, having three terminal, two junction bipolar device. Now you can say that construction. After the proper definition of the BJT, which is it is two polar, that's why bi, two junctions and three terminal. Now the next thing, the construction of BJT. What will be the proper construction of the BJT? BJT is basically categorized on the basis of its construction into two types. The first type is said to be PNP transistor, while the another one is NPN. Now the PNP transistor, in which 2p type semiconductor is placed n type semiconductor between both the regions, or you can say that n type extrinsic semiconductor is sandwiched between two p type semiconductors, while in NPN 1p type extrinsic semiconductor is sandwiched between these two type of extrinsic semiconductor. So the designing or the structure of PNP or NPN is very simple, and it is represented by PNP, and same for NPN, NPN. Since I told you this is three terminal device, now we will define the terminals for BJT. The one terminal is leftmost section, another terminal is at rightmost section, and the second terminal is in the mid. The leftmost terminal of this structure is called emitter while the rightmost terminal is called collector and the middle terminal is said to be base. Same concept will follow with NPN type. The leftmost terminal is said to be emitter. Here the rightmost terminal is called collector and the middle terminal is base. Here the highlighted part is just to show the proper contact of the terminal from the structure. So I am highlighting these three terminals. So that's why it is 3 terminal. Now the second thing is why 2 junction? Because here one junction is here between this P type and this N type, and another junction is here represented by J1 and J2. Similarly, this is J1 first junction and this is J2. Junction is nothing but a simple section where 2 type of semiconductors combine at a particular section. This is junction, this is also junction. That's why 2 junction. Now why bipolar? Because in BJT both electrons and holes, both type of charge carriers, whether it is electron or hole, both type of charge carrier plays important role for the flow of current. This is the reason that it is called bipolar junction transistor. Now the proper symbol for PNP or NPN with their terminals. I will go with the symbol, and the symbol for PNP transistor is like this with circle around it, and this particular plate is for base while this is for collector and this is for emitter. Now the important thing is arrow. What will be the arrow? Since this is PNP type, so you can see this particular plate is of P type. I am just mentioning this just to mention the proper type of the semiconductor. This is for N and this one is of P. So PNP. Now if I am talking about the flow of current, then if I am talking about the flow of the current or the direction of the flow of current always flows from positive charges to negative charges. So what will happen? Now the current will start to flow from P to N plate. So the direction of the current or the arrow is the most important, which is showing the current is flowing from emitter to base terminal from P to N. Similar symbol is for NPN with circle. Center one is base, this is collector and this is emitter. Again emitter is of N type, N, base is of P type and the collector is of N type. Now again the direction of the current is from positive to negative, so now the current will start from here to there. So the arrow is just opposite from here, from P to N. Similarly from P to N you will have to go with positive to negative. This concept only follow to mention the proper arrow whether it is PNP or NPN. So this symbol is for a PNP type and this is for NPN type. And now we will discuss the complete detail of the terminals of the transistor in terms of their sizing as well as their doping level. So 3 terminals, that is emitter, base and collector. What will be their size during designing and what will be the level of doping? Three terminal. See, emitter represented by capital E, base and collector. Emitter is one of the most important terminal. As the name indicates, this particular terminal always emits the charge carrier, and these charge carrier starts to flow from emitter and collects at collector terminal. All the charge carriers emitted by the emitter terminal starts to flow from here, and collector collects all these charge carrier, but base, this is the middle section or middle region, middle terminal of the transistor. What it will do, it will try to recombine the charge carrier coming from emitter and going toward collector. So the main work of the base is just to extract or to collect some charge carrier from emitter just in order to recombine them. So whenever we were talking about their sizing, the size of collector is kept very high in compare of emitter and base, while the second we will go with emitter, and the collector is base, and the third one is base. Collector is a terminal which collects. So in order to collect more and more charge carrier, the size of the collector terminal should be maximum, while base should be minimum, just to reduce the recombination process, so that maximum charge can start from here and can go there. That's the reason that the size of base is very small and the emitter is intermediate. Now in terms of doping means, as I told you, addition of impurity. And the most important terminal in order to emit the charge carrier is emitter. So the doping level of emitter should be very high, so that it can emit maximum number of charge carriers to extract them from here and to collect them at collector terminal. So the doping level of emitter is very high, while base is kept at center, and the collector is doped with very low concentration, so that maximum charge comes from here, recombine in very less amount at base terminal and collects at collector terminal, so that a proper conduction of current takes place in a proper direction. So after the proper clarification of the sizing and doping of all the three terminals of the transistor, the next thing is, what about the power supply, or what is the mechanism to apply biasing to any transistor? Look, basically here two conditions or two category are important for any BJT. The first is if the transistor is without any biasing, that is open circuited transistor. Open circuited means no biasing, no supply. Just to familiar with the behavior of transistor, because if there is no supply, then transistor is not in active region, but just in order to familiar with the working mechanism, or just to familiar with the proper structure of the transistor, you must have idea that what will happen when the transistor is in open circuited mode. Now the other is with biasing. What will happen when transistor is in biasing mode? So This is the important section for all of you, but firstly I will let you know just about the basic structure when transistor is operated in open circuited mode. See, whether you go with PNP or NPN, this is your choice. You can go with both of them, but I am taking here just PNP just to elaborate you about the open circuited mechanism. This is emitter, this is base, and this one is collector. So open circuited means there is no power supply at any junction or at any terminal of the transistor. Here we have two junctions, J1 and J2. Now always remember that here across the junction, whether it is J1 or J2, there is a possibility to become a depletion width across the junction. Here a depletion width or depletion region is created, and the width of this depletion region is always inversely proportional to the doping level. Depletion region or width is nothing but a particular section which always try to oppose the flow of current. So there will be depletion region or depletion width across J1 and J2 as well, but what will be the width from left section or right section, it depends upon their doping level. Now if I am talking about C, P, N, P. Now I am drawing for just to understand you about the proper width of the depletion region. See, as I told you that in terms of doping, emitter is more doped than base and base is more doped than collector. So the depletion width is inversely proportional to doping level. Thus I can say the maximum width section will toward the base region instead of collector, because it is more doped. So depletion width or depletion region is less toward base. I am marking it from dotted line, while collector is less dropped instead of base. So here the width of depletion region is more, and I am taking it right like this. You can see here this width and that section is greater than from this section just because of doping level. Similarly, when we were talking about J1 junction, for this particular section emitter is more doped than base, so the depletion region will less toward emitter instead of base, because here the doping level is less, so the depletion width will toward base. Now again this section is greater than or higher instead of this section. So this is the general structure or general mechanism when transistor is operated in open circuited mode without any power supply. Now the next is what will happen when transistor is biased, how the biasing takes place, how the batteries are connected with two junctions. So now we will go with the proper biasing, how the transistor is biased. So PNP or NPN, just take any one of them. Okay, now you have three terminals and two junctions. So in terms of power supply, here you have two options, whether you can apply battery from this section or from that section. So instead of using single battery, just because of two junctions, you will have to go with two batteries or 2 times power supply. One at this section, another is this section. Now the thing is, how the battery is connected, what terminal of the battery is connected to emitter and what terminal of battery is connected to collector and base. Basically it depends upon the application of transistor. For the different applications of transistor, the biasing mechanism will be different. Like if you want to design amplifier, as I told you, the transistor is a backbone for the designing of amplifier. So the designing of amplifier totally depend on the transistor. And if you want to go with the designing of amplifier, you will have to go with J1 junction forward biasing and J2 junction reverse biasing. I am again repeating that in order to design amplifier with the help of transistor, here you have two junctions, and in order to apply supply here, firstly with J1 junction you will have to go with forward biasing, where J2 junction it will be reverse biasing. Now what is forward biasing? When P type of semiconductor is connected to positive terminal and N type of semiconductor is connected to negative terminal, such type of biasing is said to be forward biasing, while J2 junction is reverse biasing. And what is reverse biasing? When P type of semiconductor is connected to negative terminal of the battery and N type is connected to positive terminal of the battery, then it becomes reverse biasing. So whenever you want to go with the designing of amplifier, J1 junction is always forward biased while J2 junction is reverse biased. This is the biasing mechanism if you want to go with the designing of amplifier. Now the next most important application of transistor is switching, for switching operation. If you want to design switch, or if you want to go with transistor in order to perform switching operation, then there are two proper biasing methods. By applying them, you can make transistor to perform switching operation. The first one is saturation mode, or I can say saturation region. The second is cutoff region. Okay, remember one more thing. Whenever junction 1 is forward biased and junction 2 is reverse biased, such kind of mode is said to be active region. Active region, or I can say whenever transistor is operated in active region, the designing of amplifier takes place, while for switching operation the transistor is operated for saturation region or for cutoff region. Now what is saturation region and what is cutoff region? It will be clear from this diagram only, because we are going to bias the transistor. So now what will happen in case of saturation region? Both the junction, whether it is J1 and J2, both the junctions will be forward biased, while in cutoff region J1 and J2 will be reverse biased. I am again repeating, if transistor is operated in active region, then J1 is forward biased, J2 is reverse biased, while when both the junctions are forward biased, such type of region is called saturation region, while when both the junctions of the transistor is operated in reverse biasing, it is called cutoff region. Now with saturation region, junction J1 and J2 both will be forward biased, and in order to provide the forward biasing, the P type of the semiconductor is again connected with positive terminal while N is connected with negative. So J1 is forward bias, while in order to make J2 also forward biased, the P type is again connected with positive terminal while N is with negative terminal. So it will look like this. Both the junctions are in forward biasing mode, and in such type of mechanism the transistor is operated or transistor is used for switching operation. The same concept is applicable with cutoff region, only the biasing will different. Here we have to go with the reverse biasing for both the transistor. So P type of semiconductor is connected with negative in order to make forward biasing. Similarly, the P type is connected to negative. So now both the battery is providing reverse biasing mode to both the junction. So it is clear to all of you that whenever transistor is open circuited, that means there is no power supply, there will be two junctions J1 and J2 with proper depletion region width. And whenever biasing is applied or whenever transistor is biased with supply voltage, there will be three regions. Or I can say there will be three operating region. The first is active region, second is saturation, and the third one is cutoff. In active, J1 junction will be forward biased, J2 reversed biased, while in saturation both J1 and J2 will be forward biased, while in cutoff J1 and J2 will be reversed bias. Now what kind of biasing mode or what kind of operating region is used is basically or totally depend on the application. Whenever you want to design amplifier, you will have to follow active region, or for switching operation you may go with cutoff region and saturation region as well. So in today's lecture I told you about what is transistor actually, its type. I told you about what is transistor actually in terms of bipolar, in terms of junctions with terminals. Next I discussed about the types of transistor on the basis of construction, and it had two types, PNP and NPN, their simple structure and their symbol also. The next I discussed about open circuited transistor, and the last is operating region of transistor with active, saturation and cutoff. So this is just the basic idea about the transistor, and in my next video I will go with the proper working mechanism or the operation of working of transistor. Hope you are following the content, and if you are following properly then please consider to subscribe my channel and click on bell icons to get updated for upcoming videos, and share with your friends also. Thank you so much.